Good morning, everyone. We're going to tackle our lesson for first quarter, week 6, Mantle Convection. Earth's mechanism deals with the forces acting on lithospheric plates to move in a particular direction. The motion is a result of thermal convection in the mantle due to the convection current formed. Plate tectonic theory. Plate tectonic theory was developed in 1960s, stating that the Earth's lithosphere, the crust and the upper mantle, is broken up into several pieces called plates that move slowly. It explains how the massive plates move along the different types of plate tectonics boundaries, convergent, divergent, and transform fault, where they interact, and the geologic events, earthquakes and subduction, and geologic features, formation of mountains, volcanoes, and trenches that occur at their boundaries. What makes lithospheric plates move? A convection current is a heat transfer process that involves the movement of energy from one place to another. The convection currents tend to move a fluid, gas particles, or molten rock. These are due to the differences in the densities and the temperature of a specific gas or a fluid. Due to this temperature difference, the hot fluid tends to rise as it expands, whereas cold fluid tends to sink because it contracts. Convection is one of the kinds of heat transfer. The other two are radiation and conduction. Convection. Convection current also happens in the mantle. The mantle is the second inner layer of Earth, made up of mostly hot rocks and magma. It is a very hot layer because of the heat regenerated by the core. The source of heat from the core is due to the decay or breakdown of radioactive elements. Mantle convection is a process by which thermal convection occurs in the inner layer of the Earth. The differences in the temperature at the Earth's interior and surface cause convection currents to occur with the mantle. Lithospheric plates are the parts of the uppermost layer of the Earth, and they are flowing in an area called the asthenosphere. The asthenosphere is a soft, less rigid upper part of the mantle where the lithospheric plates float and move around. Plates move slowly and continuously when the hot, less dense material rises. The rising hot material cools down in a certain area. Hence, it becomes denser than the cool. Dense material sinks that creates convection cell, with hot rising currents and cool sinking currents are regularly repeated and become a cycle. The movement of 7, the lithospheric plate, is attributed to mantle convection and considered as one of the driving mechanisms for plate motion. The lithosphere at the divergent boundary will uplift and tear apart due to the rising of hot magma. The sinking of magma pulls down the tectonic plate at a convergent boundary. Aside from mantle convection, ridge push, sliding, and slab pull are other forces that move the lithospheric plates. In a ridge push or gravitational sliding process, the old oceanic crust becomes heavier than the new oceanic crust and sinks because of the weight of the raised ridge, which pushes down the older oceanic crust towards the trench at the subduction zone. Plates move by bumping in the opposite direction and sliding past each other, resulting in making areas of volcanic activities, earthquake, and mountain formation. According to scientists, the motion is driven by a convection current mechanism within the Earth. Thank you for listening.